Okay, what we're going to do in this class now is go through how to solve computer assignment 4. There's 2 questions in there. The first question, we read in the data. This is data on individuals. We have their age, their systolic and diastolic blood pressure, and how long they take to recover from heavy exercise. So obviously, people who are less fit will take a longer time to recover than people who are more fit. We're now wanting to know how the recovery time is related to age, systolic and diastolic blood pressure. What we'll do is use multiple linear regression to do that, where we'll find a model that predicts the recovery time from age, systolic blood pressure, and diastolic blood pressure. To perform this, you go under Analyze, Regression, and then Linear. Hit that button, and up will come this dialog box. There you have to tell the program what is the dependent variable and what are the independent variables. So we want to predict recovery time from age, systolic, and diastolic blood pressure. The method we'll use is enter. This enters all 3 variables. There are other methods which do testing and eliminate variables that are not important. This one will enter all 3. Press OK, and up comes this output. First table is the model summary. It's giving you R squared adjusted. R squared is the proportion of variance in the dependent variable, recovery time, that's explained by diastolic blood pressure, age, and systolic blood pressure. 92.9% is of the variability, the variance in recovery time is explained by those 3 factors. The standard error is just the estimate of sigma. It is the square root of the mean square error residual, mean square residual in the ANOVA table. The ANOVA table is just carrying out a test. It's testing whether all 3 variables, any one of them, has an effect on recovery time. The F-test is saying, yes, there is a significant effect of these 3 variables on recovery time. The next one is the table of coefficients. The intercept is really not that important. The intercept is the predicted value of y when age and the 2 blood pressures are both 0. This is not likely to happen, okay? The ones that have a significant effect are age, p-value 0.00, and diastolic blood pressure, p-value 0.000. Systolic blood pressure has no effect on recovery time. P-value 0.170. The coefficients tell you how the dependent variable goes up and down when the independent variables are changed. So if blood pressure goes up 1 unit, recovery time goes up 12.853 units. I think the units are seconds, okay? So this is likely true. People who take longer to recover are less fit. So if you have a higher blood pressure, you're less fit and it'll take you longer to recover. For every increase of 1 unit in blood pressure, diastolic blood pressure, recovery time goes up 12.8953 units. Age, this is something that's interesting. This is a real example. This is a real example. Age, and for every increase of 1 unit, which would be 1 year in age, the recovery time goes down by 13.25 units. So this tells you that older individuals are probably more fit, take less time to recover than the younger individuals. Now you can sort of understand what this is. If you look at the age values in the data file, they range from 20 years to 30 years. So this is telling you that the 30-year-olds are more fit than the 20-year-olds. The 30-year-olds are probably spending more time in the gym. The 20-year-olds spending more time in the bar. Anyway, that's how you interpret those numbers. There's a decrease in recovery time when age goes up. There's an increase in recovery time when diastolic blood pressure goes up. The next one, we will read in the data. The data X, the predictor variable X is cell activity. The dependent variable is a binary, two-valued categorical variable. One, it's measuring whether the person who has cancer goes into remission or does not go into remission. A 1 if they go into remission, a 0 if they don't go into remission. This is the cell count. So we're going to try and use the cell count to predict the probability of going into remission. For this, we would use binary logistic regression. So you go under Analyze, Regression, and then Binary Logistic. You'd select that. Up comes this box. You then have to identify the dependent variable. The dependent variable, in this case, is the 1, 0 variable, whether the person goes into remission or not into remission. The covariates are simply independent variables. Variables that will predict the probability of going into remission. Press OK, and the analysis will come through. There's a lot of the tables that come out. This is the important one. It gives you the estimate of the coefficients, the constant term, that's beta naught, and the coefficient of X, that's beta 1. To interpret these numbers, I think the best way to interpret is do a plot of P, the probability of going into remission, versus X. So you can use Excel. You would put this function into Excel, calculate the probability of going into remission for the various values of X. From this, the person who sees this graph can read from the graph. If the cell count is 30, the chance of them going into remission is up around 90-something%. If the cell count is 10, the probability of going into remission is somewhere between 0 and 2, probably about 1.2. The constant term, it determines the value of t when x equals 0. You put x equal to 0, p is going to be e to the beta naught, e to the minus 4.3904, and it's sine 0 over 1 plus e to the minus 4.390. Beta 1 is really the slope at the 50% point. I think the best way to interpret beta naught and beta 1 is to draw a graph P versus X. Now, what I'll do is just next end the sharing, And I'll go to sharing my screen. I'm just sharing my screen right now. Close this down. Here is SPSS. So I'll start that up. Okay, so I'll open up a file. The file that I will open up is the computer science assignment for computer science 1, which I think is this one here. That's the one with where we're going to do linear regression, picking recovery time from, and if you look at the ages are ranging from 20 up to 40. So to do this, you go analyze, regression, linear. Up comes this dialog box. You have to indicate the dependent variable, the response variable, and the predictor variables, age, and the three, and the 2 blood pressures. The method is enter. You can use these more complicated methods. These are methods that will use tests and eliminate variables that are not important. The variable that was not important was systolic blood pressure, but that comes out anyway. I'll press OK. Okay, the method is enter, press OK, and out comes tables. This is the table giving R squared. R squared is an important statistic. It tells you how much of the variability in the dependent variable is explained by the predictor variables. That's fairly high. There's the ANOVA table, and the last table is the table of coefficients. The coefficients tell you how the dependent variable behaves. When you increase the predictor variables, the independent variables, by 1 unit. So we see that age is decreased, means recovery time is decreased by 13 units. As you go up 1 year, that means that people who are older are more fit than people who are younger in this study. Here's the effect of blood pressure. It increases the recovery time because if you have higher blood pressure, you are less fit. Now, then the other one was to open it up, import data, Excel. The data is, look for it. It's assignment 4.2. Okay, so this is the one. First one is just giving you different cases. It just matches up with the index there. The first one is giving cell counts, and this is telling you whether that subject went into remission with a 1, 0 for not. So then to do logistic regression, you go analyze, regression, binary logistic. Here you have to select the dependent variable. That's the variable that's either 1 or 0. It takes on 2 values. And then you have to select the predictor variable. That's the covariant. Okay, then you press OK, and it will carry out the analysis. As I said before, a lot of the terms we haven't really studied. The ones that are important are this one here, the variables in the equation, giving you beta naught, the constant term, and beta 1, the coefficient of x. Those two coefficients will determine the probability of going into remission for various cell counts. So at this point, we will stop. And if anybody has any questions, I'll be glad to answer them.
Can you just go through the binary logistic part again? I just missed that one.
Okay, now I'm going to put it up on my website, the what do you call it? The PowerPoint presentation.
Oh, okay.
Okay, I'll put that up on the website. Okay. It's very easy. Okay, if I go, this is the window is this one here. There's the data. That first one is not important. It's just going 1, 2 up to the total number of cases.
Oh, you're not sharing anything.
No, and then this is oh, I'm not showing anything, sharing it, so I have to go
Yeah,
to.
it's not showing.
Okay, now where is? Yeah, there, share screen. Okay, so here I've opened up the data in SPSS. What we're trying to do is the probability, predict the probability of y equals 1 from the value of x. These are patients who have cancer, and x is measuring a cell count, and it's related to probability of going into remission. So to analyze this, you go analyze regression, and this is all in the PowerPoint slide, okay, and binary logistic. Then you have to select the dependent variable. That's the variable that's 1 or 0, y, and the predictor variable, that's the cell count one that's labeled x in this case. Press OK, and it will carry out the analysis. There's a lot of tables that are not really that important. The one that is important is this one here. It says variables in the equation. This is the value of beta 1. This is the value of beta naught. Now, with those two values, you can set up an Excel file that calculates the probability of going into remission from those two values. To do that, I'll just set up an Excel file. Blank workbook. This will be X. This will be the probability of going into remission. This will be beta naught. I'll just call it B0 and B1. That comes from the output. B0 is minus 4.390. Beta 1 comes from, that's the 0.233.
We have to hand in this Excel file as well.
No, I would just use the Excel file to do the graph and add. Okay, so this is that. Okay, I'm going to start with x equals 0, and then x equals 0.8, so that means it'll go up by 0.8 each time. So if I go here and click on the thing, it'll construct a sequence up to, I've done it up, maybe I'll do it a bit higher. Okay, so now the formula for P is e to the beta naught plus beta 1x over 1 plus the same thing. So it's exp, that's how you do E. Now in here, it's beta naught plus beta 1 star x. Now, if you don't, I don't want the F2 to change, the 2 not to change, so I put $1 in front of that. That's a common thing in Excel. And then on the bottom, it's 1 plus that same expression. Put a space and then this. So it's just this same expression over here. So I'm not putting any dollar signs around the A2 because I want those to change. I should have had an extra bracket in there. So that's the probability of going into remission. If X, the cell count was 0, copy that formula down. You see it's when the cell count's up to around 35.2, chance of going into remission is fairly high, 97.8%. So if I wanted to draw a graph of that, I'll just select the data that I want to graph, insert a scatter plot, but a smooth graph. So there's the graph here. Along the x-axis is the cell count. Along here is the probability of going into remission. So this would be useful for a practitioner. He would be able to, if he's got information on the cell count, be able to say the cell count was 25, say go up to 25, he'd say that the person has an 80% chance of going into remission. So I don't think you have to put in these the calculations, but the graph would be useful. This graph would be useful. Plotting P versus X. A big part of statistics is writing. It's important to be able to write up your results in such a way that the person you're writing to would understand as clearly as possible what you're doing. Anyway, so I'll stop the sharing, and if there are any other questions, I'll answer them. Otherwise, we'll end the lecture now.
So what is the full list of stuff you want submitted for the assignment besides that graph?
I think the tables, okay. The table is useful, giving you beta naught and beta 1. And that graph then would really tells you how y is related to x. In particular, the probability that the person goes into remission when you know the value of X.
Okay, thank you.
So at that point, I think I'll end the lecture.